Hello everyone, my name is Sherry. I'm a production engineer at Instagram. Today my topic is cross-Atlantic scaling Instagram infrastructure from US to to Europe. Let's give you some background. Hashtag Throwback Thursday. October 6, 2010, Mike and Kevin created Instagram. They got about 20,000 users at first day of the launch. It was pretty amazing. Instagram got acquired by Facebook in 2012. And then 1 year after Instagram joined Facebook, 200 million people were using Instagram every month, and we were storing 20 billion photos. With no slowdown in sight, we began the integration. Our move from AWS servers to Facebook infrastructure. It saved us lots of money on the AWS bills. This would ease the integration with other internal Facebook systems and allow us to take advantage of tooling built to manage large-scale servers deployment. In 2014, we scaled the infrastructure from 1 to 3 data centers. To deliver a much-needed resiliency, our engineer team didn't want to relive the disaster happened to AWS in 2012, which a large storm in Virginia took down nearly half of its instance. The next 36 hours after the outage was a brutal rebuilding our entire infrastructure. That was a hard time. Actually, I was not there yet. I joined Instagram team as a production engineer early 2017, taking on the responsibility of keep scaling Instagram among Facebook data centers. Well, we still need to maintain the high reliability of our infrastructure, and it's been an exciting experience for me, to see how fast the servers can grow. And I was lucky enough to witness we reached 1 billion users this year. It was amazing. Scaling from 3 to 5 data centers was not so hard. We simply just increase the replication factors and duplicate data from one region to another. However, scaling up is more difficult if your next data center is in the other side of the continent. Here's the overview of the current Facebook data centers in use or soon to be used. The main reason Instagram wants to scale to the other side of the continent is because we have run out of space in the United States. It's a really good problem to have. Instagram, as the service continued to grow, Instagram has reached a point we have to consider leveraging Facebook's data center built in Europe. And there's an added bonus, like local data center will have a lower latency for the European users, which will create a better user experience on Instagram. So it's great. Before I talk about Instagram's infrastructure, I'd like to break down it into 2 types of service, stateless and stateful. Stateless service usually used as computing and scale based on the user traffic. Stateful service usually used as storage, and it might need to be consistent across different data centers. This is a simplified version of Instagram's infrastructure. When a request comes into one of our data centers, it will most likely to hit a Django web server first. And Django is one of those stateless services I was talking about. Everyone at my team loves stateless service because they're so easy to scale and deploy. You can just spin them up whenever and wherever you want. But the truth is, we also need the stateful service to store users' data. Well, my second favorite service is the cache layer, like Memcache. It does not really require to be consistent across different data centers, and you just spin them up and drop it down. But things get trickier with the stateful service like Cassandra. Running Cassandra with too many copies not only increases the complexity of maintaining this database, it's also a waste of capacity. Not to mention that having the quorum requests travel across the Atlantic, it's just slow. There's something you need to know about how we run Cassandra before we deploy it to Europe. Each data center have one copy. Like I said earlier, when we spin up a new data center, we just copy the data from the old region to the new region and increase the replication factor. As many of you know, you may know, like Cassandra offers a tunable consistency level for different use cases. And as for Instagram's Cassandra use case, there's quite a bit amount of them requires quorum, meaning they have to talk to the majority of the nodes for the request to succeed. And one of our, for our user requests, they could be like containing multiple Cassandra calls in one user request, meaning like they will query Cassandra several times in the request stack to succeed. Assume we use this same strategy to deploy Instagram in Europe. Here brings our latency issue. For the quorum requests coming from the European regions, the quorum requests will have to travel across the Atlantic Ocean, possibly several times, and causing the request to time out. So our users cannot load their cat pictures, sad faces. Since our problem is with the cross-ocean traffic, is there any way we can eliminate it or maybe reduce the amount of the round trip? Well, the answer is definitely yes. We introduced a new service to Instagram, Accio. It's an optimal data placement at Facebook. If you're interested about the implementation, you can find more details in our engineer blog, or there's paper we publish. So Accio is a data placement service that operates on trillions of small entities to determine how and when to move them in terms of like optimal the retrieve time for the users across the globe. Accio helps us to to reduce the dataset duplication by split the dataset into logical units with a strong locality. So you could possibly guess what we did. We partitioned Cassandra dataset into 2 units. And the idea is to have a European user's data stored in the Cassandra EU partition, and it will operate independently and keep the quorum requests within the same continent. This helped us reduce the replication factor from 8 in total to 5 in US and 3 in Europe, saving a whole lot of the storage space as well. Another thing we introduced to Instagram along with this project is social hash. I will talk about why we need it later. Social hash is an algorithm created by Facebook engineers. Again, if you're interested about details, there's a paper we published online. I will give a brief introduction of it. First, it will go through the follower graph of Instagram, take out those nodes with too many edges. It's usually celebrity accounts like Beyonce, Justin Bieber, or super famous cat account on Instagram. For example, if there's a bucket 42 and it got mapped to a Fort Worth data center by our load balancer. So all the users within this bucket, they will have their requests route to the Fort Worth data center altogether. Social hash offers us a stickiness routing for our user traffic. So this improved our cache miss rate by a lot, simply because the users from the same bucket has a higher chance of accessing the same media object. Okay, let's go back to the question why social hash helped us to partition the Cassandra dataset. Cassandra EU partition will start it with empty data because it's just a new region for Instagram just deployed. And now we can do some calculation and pick a social hash bucket which contains mostly European users, and then we route their traffic to the European Django. Accio will be tracking the accessing pattern here and then trigger the migration shortly. So by moving several buckets at once, and this allow us to gradually moving our traffic to Europe with a manageable speed. Also, like migrating a bucket together has a similar reason as a cache improvement I was talking about earlier. simply because users from the same bucket, they have higher chance of accessing the same data. Okay, now we solved our Cassandra cross-ocean latency issue. Next would be tau. Tau is a distributed data store for social graph created inside Facebook. You can find more details online. It's single master per shard, and the slave region will forward all the writes to the shard's master region, meaning there's no writes will be happen in the slave region. And then the master region is in US. Again, our latency issue. Even if all the shards has it master in ash, the write request will have to still, like from the European data center, still have to travel a long distance to reach. And ash is already our closest data center to European data centers. So you might starting to notice our real problem is actually the speed of the light. The way we solve our tau issue is to restrict the EU writes to the local region. So for write request, tau update itself locally in region. This should look almost identical to the end user. When we send a write to tau, tau will update locally and won't block the sending the writes to the master database synchronously. And the data will be immediately available to the local region, and then it will available to other region after it propagates from the local region. Similar to like before, we would just like propagate from the master region. And it offers you a rate your writes consistency. Well, you may wonder like why we don't just like split our split this tau data set using Akio again. Then we can bring our master shards to European data center. Well, it's because like tau shares different kinds of data models compared to Cassandra. For our Cassandra use case at Instagram, most of the use cases are just keyed by user ID, and the data belongs to the user itself. We use Cassandra to store user feed, stories, or metadata. We store the media ID, not the media itself. So for example, you have a feed we're going to load, then it's like user ID followed by a link of media ID, and then media ID. If it's a story, then it's like user ID, and then story ID, story ID. And those data will be mostly accessing by the user itself. Akio was able to place those entities to a region with a strong locality. But it became harder with Tau's data model. Like, I'll give you an example. It's like Sherry liked the cat photo posted by Justin Bieber, and Justin Bieber posted a cat photo liked by Mark Zuckerberg. Well, back then, Justin Bieber caused lots of hotkey issue to us, and remembering his user ID is actually a requirement for Instagram employees. Because you need to do some special operation to move the heart shards around, but now we don't have this Justin Bieber issue anymore. That's another story. So a media object can be accessed by users from all over the world, and it's really hard to split them into logical units with a high locality. That's why Akio does not really work very well with the Tau data model. Okay, let's revisit our plan. For each data center, we will still have a Django tier in the front. And then we will still have partitioned Cassandra to keep quorum requests within the same continent to keep quorum requests from traveling. And then we will have Tau writes to local region, again, like preventing them travel across the region to reach the master. Okay, now how's our disaster recovery plan looks like with this new setup? For people not familiar with disaster recovery, it's a strategy to make software system resilient to failure, from one single hard disk to the whole region destruction by a natural disaster. And our goal at Facebook is to ensure that the system that makes up Facebook and its family apps can survive the complete or partial loss of a data center region. I can give you an example. It's like a month ago, there's a Hurricane Florence. It hit South Carolina. And one of our largest data centers located there got affected, but none of our users actually noticed we lost a data center. So before we deploy Instagram to Europe, every region can take the actual load from the failure DC. Assume they all size equally, then each of the regions should only need to prepare 20% of the headroom to be able to survive one region failure, because there's 5 of them. And this design would not stand as we scale to Europe. European DCs won't be able to share the load for US region, because it's simply just not have the United States user data stored in the Cassandra partition anymore. And we need to treat it as an independent system, which means 50% of the actual headroom over there, because there's only 3 regions. Okay, sounds cool. And there's some lesson we learned along the way. First, don't rush into a new project. Before you started to provision servers in a new data center, make sure you understand why you need to deploy your service in a new region, what the dependencies are, and how things will work when this new region comes into play. And next is don't underestimate the complexity. Always build into your schedule enough time for you to make mistakes or find out unplanned blockers, or even if discover new dependencies like you didn't even know your service depends on. And because you may find yourself walked down to a path like you have to rewrite your whole infrastructure, which is basically what we did here. And then know your trade-offs. Things always comes with a price. When we partitioned our Cassandra database, we saved lots of storage space, but it also means we would need to put more Django capacity in the front, because currently the Cassandra EU partition and Cassandra US, they won't be able to share the capacity with each other anymore. So you need to treat them independently and plan the disaster recovery plan separately. And then meaning we will spend more Django in the front. Well, last but not least, be patient. Along the way of turning the European data centers, I don't remember how many times we were like, oh crap. It happens, but things just always get sorted out eventually. It might take longer than you expect, but just have patience and work together as a team. It's a super fun journey. That's it. Thanks. Questions?
So you basically did this to grow from 1 region to 2. How much is applicable if you're going to say, oh, let's open up in Japan and Australia next year?
What I like about this project is it's opened a possibility for us to scaling all over the world, because before we were only limited inside United States. Now with the project, we have the ability to scale to Europe. That means we can use the same strategy to scale to Asia. And then next, we probably split even inside our US data centers to be US East, US West, right? This just opened up a possibility of us to keep scaling even if the data center distance is really long.
Hi, I have two questions.
Sure.
One, so the architectural decision then to have TAL write to the local region and then asynchronously ship it off, is that functionality that's built within TAL, or did you have to build another service to handle that?
It's something we have to development when we find out this bottleneck. But the good part is Facebook side, they already doing lots of experiment because Facebook already scaled to European first. And then Instagram follow. That's why like we can take lots of work they already done and then just using our infrastructure. Yeah, but it is a new, basically a new feature we need to support from TAL.
Got it. And then, so in that sort of system then, how does it handle like a region failure in a DR scenario? How sensitive is that to then shifting to writing to a different region locally?
Yeah. It doesn't really affecting TAL because like when we have one region failed, then the user traffic will spread over to the rest of the region, and the local region will still have a TAL layer. So it will just write to the local TAL and still using the same structure as we used before. It's just like currently the user traffic won't be able to go to the DC, like not available.
Got it. Thank you.
Sure.
Do you all do anything special for users that have a particularly wide audience that may not even be located with the user?
Yes, we did. Actually, like with Akio, we have some use case, like we find out the accessing pattern is not limited inside one continent. So we create this global handler to place those keys, like those keys are accessing from like both region, like some celebrity profiles and pictures we do, yeah.
Thank you.
Sure. Thank you.